Good morning, people. Good afternoon from Australia. Good morning, probably for most of you in Europe. How is everybody doing? Just had my coffee. So, what's going on here? Something interesting happened in the last 2 or 3 days. I had a kind of doubt moment, completely without thinking. The other day, I asked Jacques to do a court, and there was a court that we used to play back in The Hague. It was a tennis club called Decker, and they had a beautiful wooden structure cover court. And I totally didn't realize that going for a close cover court will expose a big hole in my renderer, in my Jai custom engine. We can see basically what happens. So this should still work. So what is happening is not bad by it's definitely not bad, but the fact that so I saved it a little bit by making all this part transparent, so the sun can come in from a side, which gives an interesting effect. But what is happening is that on this side, so if we didn't have the sun, and we can see here what's going on, yeah, we don't have any kind of attempt to ambient occlusion or any kind of global illumination. So everything down here looks incredibly flat. And this was a sort of kind of a own goal, but I'm glad that it happened, because it really showed me, like, okay, so I have two options here. I have two options. You know, I either go for outside courts only, or I will have to write ambient occlusion. I will have to write. I already have a code for a spotlight, but I don't have the shadows for the spotlight. Actually, that's not true. I have code for a point light, not for a spotlight. So, and that made me realize that I really don't feel it. I don't feel it. I really want to work on the game. And I really don't want to spend weeks doing this stuff on the render. So I said, all right, okay, let's see how much of a pain is going to be to migrate to Godot. So 6.0. Yes, okay, because I'm not moving at all. Okay, fantastic. That makes sense. So that's what I've been doing since pretty much yesterday. So this is as far as I got. So let's have a look at the difference, right? What something like Godot buys me. So very similar scene here. But straight away we got a much better situation here in the place where we don't have sun. Hopefully it comes out on the stream. There are a couple of things. Obviously we have some ambient occlusion going on. I also have a spotlight right on the top of the court, which is giving us like very faint shadows down here. There is definitely more shape going on this side of the court, and something interesting is that because of the spotlight, it is a very interesting effect, because down here on the feet we get ambient occlusion. As I move, the shadow from the spotlight starts to appear. It kind of moves, and by the time I am in the center of the court, it is exactly above us. So the first impression was good. I got as far as get some the animation system working, so I can get in position for a forehand and shoot. Because we don't have a ball yet, I also have the backhand, but I have to trigger it by code. We don't have a ball yet, so there is no way to decide if we're going to play a forehand or a backhand. So yeah, let's continue. Let's continue and see where this is bringing us. You know, how it feels. I actually really enjoy C#. So it's not a language that I hate, especially when it comes to modern C#. At this stage, my project, I switched to Net 10. I'm not sure is actually completely supported in Godot or not, but we are there, so that's fine. Let's write 1 second the what's my to do for today. So what I would like to achieve today. And basically what we want to do, we want to get like, you know, a first ball and hit. Which basically what it means is from this situation. So imagine we create some kind of, so what is happening right here is that you see that there is this ball appearing from behind me. And this is kind of, in this situation, we are simulating like a training session, where if you've seen some tennis training session, usually there is like the coach behind the player that is kind of feeding the first ball, and then the players play it out. So the idea, what we want to achieve exactly what we're seeing now. So we want to see the ball coming, the first ball coming from that direction, right? And then I'm able to move and hit the ball, and the ball will go on the other side. Let's see if we can do that, and let's see how complicated it's going to be. All right. So we start from a ball. Since we are in C#, we're going to follow the C# habit of creating a new file for the ball. One thing that you might notice is that I'm not writing this particularly in Godot style. So I'm trying to write as much as possible as standard C#, and only interacting with the Godot stuff when it's time to do stuff with Godot. This morning I spent most of my time working on the input. I had to basically override the entire Godot system. So our ball here is not a node, is not a Godot node. It's not a partial class, right? It's a full class. And we're going to have some constants, we're going to have some data, and we're going to have some functions, right? And the data is going to be super simple. is going to be for sure a position, right? And then we're going to have a velocity. Right? I can reference here my code in Jai to see what we had. So our ball had a ball state, where a ball state is position, velocity, spin, number of bounce, and fold. I had this division because my approach with the version that I have in Jai is to run the simulation on a separate thread at specific intervals. Because here I was able to interact with the new game input API in Windows. I can actually do the entire thing single thread and simplify the code a lot, while maintaining the kind of precision of timing in the inputs that I need. So let's say that we will do the spin later. So and also the fold later. So let's add for now only the bounce count. Okay. So far, so good. Then in this, we have the concept of a match. In Jai, I had a kind of a global thing where it contained the balls and the players. And it's something that I was already thinking, maybe it's not what I want to do. Maybe I want to have a concept of a match, because what I would like to have is, you see we have other chords here. What I would like to have is, while you're playing your match, somebody is also going to play a match here. Potentially a match, or been training there. Potentially a match from the same tournament that you're playing. So that could be interesting. The idea, my idea is that if I can simulate a match really quickly, and when I say quickly, I say 20 seconds maximum. If I can kind of fast forward the match simulation and get it done in 10, 20 seconds, it would be interesting to have some kind of something similar to a Football Manager, where you get the results of the matches in your tournament, and if you want, you can actually go there and watch the replay or the highlights of that match, or you can watch the full match of your opponent. So that would be cool, instead of just getting like a random simulated result. You can actually get the AI to play against each other. I'm still not sure if I'm going to have a procedurally generated AI. So imagine a situation. So the way this game should work is something like you start a season, and you will have a number of players in this season, say 64 players or 128 players, something like that. Yeah, we'll have to see what's a reasonable number. Maybe it's too much, right? Maybe we want the player to get familiar with these opponents, so they could even be like 32 players, and you play with these players, a seasons of tournament, say like 10 tournaments, 20 tournaments, right? That we will see what the season is. Now, one way to do this would be for me to manually create the players. The advantage is that we can have way more control on how the season is going to be if I create all the players. We can also be a little bit more consistent in how the player is going to look, what the player is going to wear, what the shots of the players are going to be, right? So there's going to be more control. The other way to do it would be to do it procedurally. So to generate this player procedurally when the season starts. And that obviously will make the game a little bit more difficult to test, because every time you generate a season, you have no idea what your players are going to find, because potentially they're all different, but it will add a lot of possibility to replay the game over and over, because everything is going to look different season by season. Why was I even talking about this? And why I came here, I absolutely don't remember. Yes, because I was talking about the concept of the match, right? So in Jai, I had the players and the ball as global variables. Here I have the concept of a match, and the match owns the player and the ball, right? So right now, then I have a match avatar, which is, the game side, and is actually a node in Godot, but, I could have nothing stops me from having a list of matches in this thing. So we can see players playing around us, which is cool. Okay. So our match is going to have a ball. So it's going to have players, and it's going to have a ball. Public, ball, right? Which is going to be a new ball. As simple as that. I think the ball can be stupid. Probably the only thing that the ball needs to know is about the court data. So every court will have its own data regarding how the ball bounces. Right, so if you have a clay court, the bounce is going to be different from a hard court. It's going to be different from a grass court, and so on. So eventually, the ball will have to know about the court. And I already have a court class that doesn't do anything at the moment. It doesn't even have data. So I wonder if I will create this ball in the actual constructor of match, right? So we're going to have ball equal new ball. And for now, again, we don't need anything in this ball. So we're good like this. Let's have the ball just bounce in the center of the court, right? So let's get the ball to start at 0, 2 meters in the air, 0, right? And that's where the ball is going to be, right? For sure, the ball is going to have a public void step method that will do the integration of the movement of the ball, and then what we're going to have is a ball avatar. Now, probably the ball avatar is a little bit overkill, so probably I don't need that. So let's simplify this a little bit for now. So let's say that inside our match avatar, so if you follow Adafall generation and also Assetto Corsa, I always have this concept, right? Is like you have a class. Imagine, you have a car. In this case, in this game, we have players, so we have balls. In Hydrofall generation, we had boats. And that represents the simulation of the game. And then we have the avatar, and the avatar is the one that is responsible to show that thing on the screen, right? And it's a system that fundamentally is also abstracting replay, Right, so once we will have a replay, the idea is that the avatar will get an input that, you know, it's like a player state, a boat state, a car state, and it doesn't know where that input is coming from, and it's just visualizing it. So the replay comes for free. You just have to feed the avatar with a recorded state. So let's say that inside our match avatar, we have a node 3D that we will call, you know, the ball node, right? Let's import this thing into our project in Godot. All right. So here we will have balls, right? I really don't know if I'm going to have multiple balls or I'm going to have the ball, but just in case, let's create something called ball 0. As simple as that. And let's go and grab it from our old game. And nice thing about Godot, GLB works really well. So this is pretty easy. So we got tennis, ball, and we got the ball. Here's the ball. What's everybody's asking this question about the my view on AI. I don't know. I'm not. It's not something that really interests me. So the entire point is that I enjoy coding. So I don't look into the AI because it removes the thing that I enjoy, which is writing code. So if somebody else, if something else is doing the fun part for me, it's not fun anymore. Alesua, hi to you as well. Welcome. So we got this ball. As simple as that. Let me quickly do something on this thing, which is extract the material. So we can do something with this material. We want it quite rough. And I'm going to put a little bit of emission because we want the ball to be almost like fluorescent. Right, so actually we can go, we don't want to exaggerate, but, you know, a little bit, that's too much. Because I think the emission is, I wonder if operator add, okay, hold on. Operator multiply. Okay, that's what we want. Although what we really want, we would really like to raise the ambient component of this thing. I don't think we have something like that. So let's not spend too much time on this. Right, so we got our thing here. So in the code, and this is what I was telling you that, yeah, so we're not gonna put this thing into the scene. We're gonna actually instantiate this thing with code. Right? So when this thing starts, right, we're gonna create the ball. Right? Create the ball. Right? And the way we do it is similar to the way we do it for the players. Eventually, I will do this for the court as well. So that's pretty much what we're doing with this thing. So this is going to be balls, and this is going to be ball 0, and this is going to be ball GLB, right? Balls, ball 0, ball GLB. All right, all good. Okay, And then this is going to be ball node. We're going to do that. Okay. Do I play tennis in real life? Yes. Yes, I do. Yes, I do. It was my first huge passion as a kid. So I played from 8-9 years old to about 17 years old. And then I stopped playing for a while, for a long while. And then I started again about 3 or 4 years ago. So obviously I really suck right now, but I think I know about the game. I think I know about the sport enough to make a game about it. Should we have this? Really don't know if I'm supposed to call this base ready before or after my code. I'm really not sure. Anywho, so we create this ball node and we add it to the scene ball node. Cool. This should. Do you play pickleball? No, pickleball. I'm from Europe. I live in Australia, but I'm from Europe, and in Europe, pickleball is not a thing. From what I see on YouTube, I'm not a fan. Let's put it this way. I'm not a fan. No. But before, what is very popular in Europe is paddle. Paddle is an alternative tennis that is much easier tennis, much easier. So actually, the way I ended up playing tennis again was that I went to play with my wife paddle just to try, and after 3 or 4 times that we went, I was like, all right, let me do the real thing, and I ended up playing tennis. So I haven't played paddle for a while. Here in Australia, there are a couple of paddle courts around here, but they're not that close. Sometimes at the tennis public court here, I saw some people showing up and try to play pickleball. I don't know. I think it looks ridiculous. Sorry. I'm very sorry. It looks ridiculous. All right, so we got the ball in the scene, but we cannot see it. But it's all good. Because what we need to do is just set the position. So ball node position is going to be match ball position. So now we should be able to see the ball in the middle of the court. I don't see any ball here. Here it is. Right here. I know it's hard to see probably on the stream, but trust me, it's there. It's right in the... is in a unfortunate place. Let's put this ball a little bit lower. The other thing that I like about Godot is that I can treat it pretty much almost like it's my own engine. I can start it from Visual Studio Code, without passing through the editor. So it's not like Unity that has got this. Maybe Unity has some kind of plugin for Visual Studio or for Rider to start like this. But, Visual Studio Code is pretty much there. All right, so our ball is there. So that's our ball. We're all happy about having our ball. Now let's get our ball to move. So in match step, interesting question is, do we move the ball before or after the players? That's a good question. For now, let's do this. All right, so what's going to happen here is that we're going to have what was it? Step ball. Blah 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 blah. So I can. Okay, hold on. This is very important. Hold on. Did you make it from to Godot from? Yeah, that's what I'm doing today. I had a game working in Jai with a custom engine, but today I'm experimenting, migrating it to Godot, just because I'm not in the mood to write more renderer stuff. I really just want to play the game. I want to work on the game. Right, so we could copy this code, to be honest with you. But before we do that, we need a different method. Because what we're going to need is all step result step once, right? And this step once wants vector 3 pos, vector 3 vel float spin, right? And probably is good in Jai. What we had here, we had pos 0 vel 0 spin dt and step mode full. What does this thing do? I'm not using the mode. Is mode, that's it. There it is. Right, okay. Good morning. Is C# the default for Godot? No, actually the preferred way is the Godot internal language, which is called GDScript, that you can actually use from inside Godot. But I don't know GDScript. I know that is similar, kind of similar to Python, but you know, I know C# well enough, so for me it's just a no-brainer. I believe also the performance are better if you use C#. From what I understand, in the past, the C# side was not as updated as the GDScript, but from my understanding, they are pretty much the same now. So, interestingly, there is another option, which is you know, you can also use C++ and Rust to do stuff with Godot, which is very interesting. Rust is so hard. Yeah, it's not easy. My last game, the last game that I did was in Rust with a custom engine. I like it. But you're right. It's not easy. It's not easy. Okay, so if we want to really just copy this code, let's see how it feels if we copy this code. Let's see how hard it is. Let's get to here. See how hard it is to translate from Jai to C#. So this is the square length. length squared. Fair enough. So drag equal minus ball drag. Okay, so ball drag is going to be a constant. So constant float ball drag. And our ball drag constant came out to be this. In order to calculate, I'm gonna need all this stuff. Ball radius. All right. So let's bring this stuff in. So we're gonna need all these constants here. So it's gonna be constant float. Let's get rid of all the ball. Obviously, it's the ball, right? We are in a class called ball, so these are all stuff. The area of the ball is this. Is radius by pi, matf pi. Okay. Weight of the ball and drag. Cool. Nice. Hey, Marcel, you. Oh my God, we got an expert here. How you doing? How you doing? The big expert in Godot. Marcel is working on a racing game called The Last Garage, right, Marcel? And it's using Godot, and I believe he's writing all the physics in C++. I think you're writing the physics in C++, right? Are you writing it in the Godot system itself, or you're writing it as a separate DLL that then you? Right. Thanks a lot. A bit busy. It's Saturday. We're really not supposed to work. By the way, I'm talking to Marcel from YouTube, so I'm streaming both on Twitch and YouTube. Last time for Twitch viewers, this was very confusing. We're like, who am I talking to? So I'm talking to Marcel Offermans from YouTube comments. Physics is in C++ as a GD extension, right? Okay, so you went with the GD extension. Interesting. Obviously, for a racing simulation, performance is absolutely paramount, right? So I think C# is good enough for something like this. But if you're going for a car physics, you want something much faster. So C++ and Rust are the way to go. Is car physics special? It's incredibly complicated. It's incredibly complex. So compared to a typical game where you have the controller for a character or something, I would say probably the code for a car simulator is probably 20 times the code, something like that. It's really complex. I mean, if you want to do like a serious racing simulation like Marcel is doing, it's tons of code. It's easily, maybe in the hundreds of thousands lines of code, something like that. Why though? It doesn't sound complex, just moving blocks. Yeah, because it's not like that. When you have a simulator, the body of the car to start with is not a single body, is usually like two or more bodies, because basically what you do, again, I'm talking about serious simulation stuff. You want to also simulate kind of the torsional rigidity of a car chassis. So the car chassis is not rigid, really. It kind of rigid, but not. And then you have more bodies for the wheels, and then you have all the connection from the wheels, between the wheels and the body of the car. And these things are super important because the way the tire, as the tire is moving up and down compared to the car, the tire is not going up and down vertically. It's kind of moving, right, in a kind of an arc, in a way. So it's changing his geometry compared to the road as it's moving up and down in the car. And you need to simulate all this stuff. This stuff is what makes a car different from another car. And then you have, and then you have the drivetrain, and then you have the most complex things, which is the tire model. So it's like how you calculate the intersection between the tire and the road, and once you have those intersections, how you generate forces from those contact points. That's probably the most important part of every racing simulation. It takes a big part of it, but there are also other parts that are important. The drivetrain simulation, so engine, gearbox, engine, clutch, gearbox, differential, other differential if you have a 4x4, how you simulate all those, how they vibrate, how they slip. My favorite car game is the one that I work on. It's the one that I did, which is Assetto Corsa. Cyberpunk is, Cyberpunk, you're correct. It's a car game. In case of myself and Marcel, we're talking about racing simulations, which is a different class of games. So you're talking about Assetto Corsa in my case, R Factor in Marcel, or other things like iRacing. What else is there? Le Mans, which also belongs to Marcel's old company. Yeah. BMG, BMG is a borderline. The approach of BMG is completely different from what I do with Assetto Corsa, and I believe what Marcel does with our factory in the last garage. So obviously the approach in BMG works really well for things like crashes and so on. But I think they are trying to push more into the racing, the actual racing. Imagine Cyberpunk with realistic physics, yeah. Well, probably, who knows, maybe it will not be that fun to play. Sometimes I think about, maybe I give my big game idea. Doesn't matter because I don't have the money to do it anyway. But sometimes I imagine like a game with kind of realistic physics. But it's more like a like mission scenarios things, like imagine you are in the middle of a bit of a Jack Ryan thing, like you are in the middle of a revolution and you have to drive an ambassador from the embassy to the airport, right? So you have to drive and there are bad guys shooting at you and so on. So that could be cool, but who knows? Yes, I'm simulating also car physics. Hey, Miro, how you doing, man? Miro is another car simulator developer. Also fuel tank. Yeah, fuel tank is another body that you can add on the top of the simulation. I think some people go as far as simulating how the fuel moving into the tank can change the CG position as you're going through a corner. Race car simulator guys are a little bit crazy. N64 scene, I'm not really. I'm really a PC guy, so I'm not big. Very crazy. We are completely crazy. We are completely. But you know, Marcel, I'm out. I'm over it. You're not. You're still in it. I still don't know how. Yeah. I think I remember before I started Assetto Corsa, I was looking at the predecessor of Beam, which was, what was it called? Rigor Roads. I think it's exactly. I don't know if the same guys that did Rigor Roads. Yeah. I don't know if they're the same guys or same idea. You know, it's the same idea. But what I found was that it was like, yeah, okay, this is cool. It's super cool, but it's so much work. And if you actually have the data from a real car, you know, imagine trying to match something like rotational inertia of a body, and you're trying to do it with sticks. So yeah. So I did some experiments. Where, you know, like the body of the car was really made by a box that was held together by rods. Because also I didn't like the idea of, I think one of the problems that you have with something like Beam is you either run the entire simulation on a GPU with all the problems that come with that, or you basically have to constantly send all the vertices to the GPU every frame. So it's never, the performance is always going to be a little bit problematic, I think, because that's a lot of data. If you have to update all the vertices every step of the simulation, it's, you know, it can get a little bit slow. Although it's not very dissimilar from also doing things like particle. Although particles, you do it on GPU these days. So I remember the time when I was thinking about this. It was, you know, what we're talking about 2010. I was literally about to start Assetto Corsa, and I was doing these experiments, and I was just scared that the performance will never be there. Stefano, you inspired me to use ODE physics and make my own render, which I mean, DirectX 11, basically same technology. I'm very behind on technology. Yeah, like, I mean, the new Assetto Corsa, they're still using ODE. So it still does what you need. I think Jolt is good, but it's very C++. It's really what I like about ODE. Internally, ODE is C++, but old style C++, but it's got a C API, so it's very easy to interface it from other languages, and the interface is very, very clear. But a Jolt has got this super C++ interface, which is a little bit annoying. I was using it from Jai, and it was a little bit of a pain in the ass, but I think it's good. Rust has a very good physics engine coming up called Rapier 3D, which is what I used for Hydrofoil Generation, my previous game, the sailing game. I started with ODE, and in the middle, I was tired of having to write, you know, interface to this native library. So, you know, I tried this Rapier, which is native Rust, and makes things much, much easier. In Ideolo, you will probably combine the technique and use some form of co-simulation to merge those techniques together. Godot uses Jolt. Yeah. Yeah. They switch it to the default. Yeah. In this game, in my tennis game, I'm not going to use the physics at all. Well, probably I will use the physics to do things like skirts and flags and things like that. So cloth, to do cloth simulation. But all the ball physics is all written by hand because it's very simple. It's not difficult. And talking about DirectX 11, yes, I spent the last couple of years porting my stuff to Vulkan, and it's a pain. It's not nice. It's not a good place to be. I think graphics programming at the moment is not in a good place. I had a look at something that looked promising to me, and it's basically SDL3 has got something called SDL GPU or something like that. And it looks like they managed to simplify it's a nice API. It looks much easier to use even than something like Web GPU, which I like. Web GPU. Web GPU I tried in Rust, which is called WGPU, and the performance was terrible. And it's not. There were a couple of problems. The first problem was that they have their own shading language, so you have to rewrite all your shaders in this language that is not even nice. And the performance was really bad. And coding for WGPU is not much easier than Vulkan itself. So once you've done that, just do Vulkan and call it a day. Yeah, WGPU has, at least when I tried, I'm talking about quite some years ago, they had big problems, and I think they still have. If you look around the internet, you will find a thread talking about this. They have big problems where they do too much work trying to track what resources need to change state, and the performance is just not good, right? If you write the thing in Vulkan or in DirectX 11, you will be completely destroying WGPU, completely destroying it. Right? If you look into the source code, if you look what they do for a draw call, if you look at the code, you will see that it's insane, the amount of work that they do. So yeah, there you go. I don't know if the Google, what is called Dawn, is Google has another implementation of WebGPU. Honestly, I don't know if they are better than WGPU, but at the time I was very excited because shit, this is using Vulkan, so my game is gonna be faster. So I spent 3 weeks, I think, porting my ceiling game to that, only to discover that it was going much slower than DirectX 11. And it's not that I wasn't doing anything fancy in DirectX 11. For me, DirectX 11 is still the perfect API. That's where the complexity level should be. But obviously we are going towards a very different world. We're going towards a world where people writing your own engine to make a game is not a thing anymore. Like I realize now, how quickly I move using Godot compared to my own engine. So obviously these API are supposed to be used by engine developers, and then you write the game on top of it. The world where a developer writes the engine and the game, I think it's shrinking more and more. It's becoming more and more. I just give up about Vulkan. Yeah, yeah. It can be very depressing. So what made me take a look at Godot out of interest? Yeah, I was explaining that basically what happened was that I asked my wife to create a tennis court that we used to play on, and I didn't think about the fact that it's an indoor court, and then I realized that in my engine I don't have ambient occlusions, I don't have spotlights, I don't have spotlights with shadows, I don't have global illumination. So everything here that is not hit by the sun is incredibly flat. At the beginning, when I first load this, actually it was completely closed. Then I cheated and I kind of removed this wall. So now I have the sun coming in doing this nice effect. So it's nice when you are in the sun, but it's not nice when you're here, everything is incredibly flat. And I realized that I really didn't want to do this work. I didn't want to go in my renderer and write that ambient occlusion and write the shadow spotlight. I really didn't want to do. I don't want to do it. I want to do the game. So I'm giving it a try. I don't know. Maybe I'm going to stick with my own engine. I don't know. At the end of the day, this is even a simple game like a tennis game. You're still talking about at least 2 years development time, right? It's going to take at least a couple of years. So if you look at it from that point of view, right? Okay, global illumination, I'm not going to be able to do it, right? I'm not going to do it. There is no way I'm going to do global illumination. It's just too much work. But everything else, when it comes to spotlights with shadow, they are not really that difficult. Ambient occlusion, it's annoying, it's not really that difficult. So probably it's going to cost me a couple of months, right, of development. And if you look at a couple of months over 2 years, it's not that bad, right? So I'm not done with my decision, but I saw my wife downloading Godot, loading the court and playing with the camera effects and stuff, and things look good straight away. Obviously it has a potential. Honestly, try GDScript. Yeah, I have to see how it interacts with everything else. I'm not closing the door. If you are over 50, don't write the engine by yourself. Life will be too short. Well, the thing is that, writing an engine, it really depends on how much experience you have. Like I have done this been doing this for like 30 years, right? So, it doesn't take me that long. It's all pretty much stuff that I've done already. Right, so my last game, I wrote the engine. I wrote it in DirectX 11, so obviously in Vulkan it's more difficult, but I've been there, I've done that. So it's not like starting from scratch that is going to take you years to write an engine. Right, so I also use DirectX 11 for my engine, and I hate newer graphic API. They're just too complicated for indie devs. That's what I'm saying. They are not really... The target is not the studio that does their own engine and the game, right? It's very obvious we're going towards a world where you either are an engine developer and you're working on Godot, on Unreal, in Unity, Unigine, you're doing one of this, whatever the Amazon thing, CryEngine, if it exists, right? So you either work on those and you don't work on games, or you're making games and you're using an engine, right? I think the time for a small studio to be able to write their own engine and the game is coming to an end, probably, sadly. Can we use F sharp with Godot? I think you can. I think you can. Yes. Yeah. Yes. Whether you want, I don't know, but yeah, you can. Yeah, I like F sharp, but probably for games, I'm not sure. I'm not sure. Maybe one of these days I'm gonna try. The nice thing I think is that it should be pretty easy to mix the two. So you know, I could write like the simulation part in F sharp. The thing is that the compiler, the F sharp compiler, is a little bit slower than C sharp. Slower both in compiling and at runtime. So I don't know if it's really pays. It's not supported out of the box, but an API being able to integrate other languages. Right? I don't know. I think you should be able to use F sharp. I remember I tried it. Should be a problem. I really hope they just open GPU more, and with better API, maybe Vulkan 2.0. There are, at the moment, there is no indication. You know, I'm hoping for. Right now, seriously, I think the best thing that we have at the moment, but I haven't used. I've done like, I don't know, maybe load the model, or maybe just a triangle. I don't remember what I did, but you know, I had a look at it. Probably the best thing that we have at the moment is that SDL3 GPU API, but I don't know. I don't know the details. It looks like an API that is actually usable. Is the compilation speed of Jai a distinctive advantage? It depends. I mean, you can keep. The thing with Jai is that compilation speed is. Jai is always recompiling everything. So it's going through the entire source code, including the standard library. So everything that is in there, it gets recompiled every single time. That means that basically there's no how it's called. The word escapes me. Where basically you just recompile what is changed, right? So imagine a situation if you know C++ or if you know Rust or whatever, right? In Rust, you recompile only the modules that you change, that they are dependent from what you change. So for example, in a situation like in a C++ engine, if you change something in your math code, whatever, you will have to recompile the entire thing, and it's incredibly slow. No, it's not on module, incremental. There you go. UVVW, incremental compilation. That's the word that I was looking for. So in Jai, I'll give you an example, right? So, because an example is, so in Jai, this is what it takes to build my editor and my game, right? So it's sub 1 second and the shaders. So it takes 0.6 seconds for the editor and 1.22 seconds for the game that is doing probably also the shaders. So it's incredibly fast, but we are in debug mode. So the debug mode is super fast to compile. If I want to build the release version of the game, right? This is how long it takes, the release version. Still building. There you go. So how long it took? Hopefully it didn't clean the... I cleaned the output. I don't have a build, but you saw that it was longer. Now, the amount of code that I have is very, very small. But you can imagine that I think when Jonathan Blow recompiles his entire game in release mode, I think he does it in the Wookers podcast. I think he rebuilds. It takes quite a long time. Right? It takes quite a long time. But how often you need to build the release? That's a very good question, because one thing that I notice in Jai is that the debug performance is really good. And that's because the language is so simple that, you know, it really doesn't need to change that much. So, for example, if you try to run, for example, in my sailing game, I could not run it in debug mode in Rust, right? It was too slow. It was not able to calculate the physics in time if I was in debug mode. So for me, like, debug mode didn't even exist. But my sailing game, if I did a change, you know, wherever I did the change, in release mode, it will take like 8 seconds to build, which is not bad. Release mode with incremental compilation. So it's not really that bad. And because you can separate things in different crates in Rust, and you just build the crates that change, that really put the compilation time down. Plus, Rust has a nice thing, which is called cargo check. So to give you an example, if I load my Rust code, let's get it to load 1 second. Takes a long time to analyze the code, so still doing it. This is just the LSP working out all the things. Have I missed something? I knew you were back to Esievo this time doing a proprietary graphic engine. Anyway, welcome. Yeah, you missed the fact that I left around November. So yeah, I'm back doing my own stupid stuff. All right, so in my Rust code, if I do a very simple change like this, right? And I do the cargo check. So the cargo check is not a full compilation. So it's not creating the executable. It's just going through the code and make sure that stuff are correct. So if I do a cargo check, it's done in 1 second. So it's done in 1.12 seconds, right? Which is very good. I don't have the executable yet. So if I need the executable, it's going to take longer. So now I run it. It's building. And this is debug mode. And here we go. So it's not that bad. It's not that bad. So yeah, to answer your question, I'm not. So the real question is, okay, if once you have a project that is really, really big, like Jonathan Blow project, which is, I think, 300,000 lines, I think in debug mode, you're still looking to some seconds to build. And in my experience, Rust with properly subdivided crates is not that far from it. So it might be a little bit overblown, the Jai performance. Meanwhile, can you tell what CPU I'm using? I'm using an AMD 56. I think nothing special. Where is it? Can you see it? I'm blind. Where it is supposed to be? There it is. 5600X 6-core processor. Yeah, obviously, and that's another big difference, where in something like Rust, C++, your compilation is using all the cores. Jai is a single core compiler, which also means that potentially there is a lot of improvement that can be done there. Are you going to have a new record? Why not? Why not? I think, yeah, why not? Why not? But yeah, as I was saying, how often you need to build a release version. Yeah, for my sailing game, like every single time. Like the debug version, I think it didn't even build anymore. Yeah, at a certain point, you stop building, but I never use it. In something like Assetto Corsa in C++, only release version, like no debug version. So for me, Jai is the first language where I can actually use the debug, and it's fast enough. Is your programming style more or less language independent? I tend to adapt, I think, to languages. So obviously, if I'm in C#, I do stuff a little bit more object oriented, but I never was big on object oriented stuff. So it's very rare that you see me writing hierarchies and things like that. I write interfaces sometimes. So yeah, I would say, yeah, I don't think it's that different. My debug version of the physics are almost 2 orders of magnitude lower than the release builder. There you go. Yeah, Marcel is confirming, right? Especially when you're doing simulation stuff at very high rates. Like, you have to think that something like a racing simulation, in case of something like Assetto Corsa, you're running at 300, 500, up to 1000 hertz. So you have a couple of milliseconds to calculate your new situation, right? For both your car and the other cars, and to run the AI and so on. So it doesn't take long in the project before debug mode becomes completely useless, completely unusable. What GPU? 3070 GPU. For this game, I really don't care, because my main target will be something like a Steam Deck. So, and the problem is not really the graphics. When it comes to the kind of games that I do, that Marcel does, not this game, tennis game is not going to be a problem for performance, but my sailing game, my racing simulation games, the problem is not the graphics, is really the physics. The physics, you can't run it in debug mode, is impossible. Yeah, and also that's the reason why, for example, for all the Assetto Corsa stuff, I almost never use a debugger. I started to use the debugger really with Jai, because again, the language is so simple that the debug experience with the debugger is really, really good. You can see everything because it's even in debug mode. For example, if you try to do debug in Rust, it's a mess, because a lot of things, even in debug, are, all the iterator stuff that Rust does. That code, the code that you see on the screen is very different from the code that is actually expanded into. So once you go into debug mode, is not a nice experience. I was curious about the CPU because my life is C# in JavaScript, and I hate the time it takes, and only am able to get it faster with more cores. I think C# is a decently fast compiler. I don't think C# is. I don't know. I did an entire project in C# before I did Assetto Corsa. I did a simulator for some Italian driving school, and it was a mix of C++ and C#. So it was quite a bit of code, and the compiler was very fast. The project only takes a minute to build on C# side. Jesus Christ. And more on JavaScript. But is that even for small changes? Or you're rebuilding everything? A minute in C#, Sounds like completely insane. It should be able to figure it out. It should be able to figure out, C# should be able to figure out what really needed to build. So I think that the secret is to, for sure, separate assemblies, for sure. Right. It's a job in a job, like, and sadly is very difficult to do when you are too deep into a project. But keeping compile time under control is something that should be a discipline thing that you have to keep doing throughout the project, right? C# should be able to incrementally compile what you have. At least Java can do that. Yeah, I remember the C# compiler being really, really fast. I hope I don't get surprises here. Right now, I think for the code that I have, which is very small code, I'm already slower than Jai, but I'm still into the 1 second build time. Meanwhile, I keep translating this code from Jai. We need a DT. All right, so if velocity I hate, this is something that I don't like, for example, why you have to put capital letters. I really don't like the code style in C# from Microsoft, all the uppercase. More, I used to work in a CEVO. No, I left around November. You're porting from Go to C#. I'm porting from Jai to C#. Jai is the language that I've been using until today. All right, so I don't have these functions. I think I need to find how to, I need an extension method here. I need some extension methods for the, so let's do a new script called JuxVein math. The problem is that I don't remember. I don't remember how to do extension methods, so I need to check 1 second. C# extension methods. So public static class extension. All right, so let's see. So I imagine this is the type, so vector 3 v, and our extension is going to be vector 3 x0 z, which is basically is giving us bx0 vz. Okay, that means that now I should be able to do this. So this is del xz. Did I write it as a property? Yeah. Okay. Can I write it as a property? It's actually not bad. It doesn't look bad. Does it work? Yes, that's kind of cool. So we need the court information to do this. Okay, so let's do like this. Public strat court data. Okay, float friction. And this by default we put it at how come questions disappear? Which question? What question do you ask? I think I never used struct in C++. Well, struct is the secret that makes C# faster than Java. Well, maybe the new Java is, maybe they fixed it. Because structs don't hit the garbage collector. So from a performance point of view, they're a major win. I ask you if you have certain parts where you use real functional programming. No. I mean, this function that I'm writing right now, you can almost look at it as a functional because this is a pure function, but it's an exception. You know, most of the time it's a waste of performance. But this function in particular, it doesn't reach for anything outside. So why do you change programming language so often? I've seen you creating. I enjoy. I really well. First of all, I'm no. I enjoy. I enjoy. I think that unless you do like a full project, you will really never understand the strength of something. You can have an idea by doing small experiments, but you can never really understand. I was very, for this tennis game, I was really not convinced because when I started, I had basically a Jai engine and a Rust engine, both in Vulkan, both pretty much at the same level of development. So I decided to go with Jai. Now, I realized that I'm not really in the mood to write engine stuff, especially renderer stuff. I don't want to. I want to concentrate on the game. That's why I'm trying now how it feels to work with Godot. So far, so good. So it's not as cool as working with Jai or with Rust. Granted that if I really want, I can write it in Rust with Godot. And what's your favorite language for games you've been working so far? They have different strengths. I don't think I have a favorite language. At the end, when the project is near the end, I really like Rust because it made me feel, when I released Hydrofall Generation, I never felt so confident that the thing was going to work. I never had that feeling. Like, with Rust, I really felt like this thing is going to work. Right? There is no way that this thing is going to crash. And in fact, from that point of view, the sales were not great, but the quality of the software was amazing. So obviously Rust makes you work hard to get to what you want, but when the program's built, you can be pretty confident that you didn't fuck it up. That it's almost impossible that you have a data race. It's very robust. I think I still have the game servers for the sailing game running, and I think it's been more than 1 year now. They've just been running, no crash, nothing. They're still there. So obviously it feels really good. It doesn't feel good at the very beginning of a project where you're trying to understand what you're doing. That's, I think, where Jai is very strong, where, you don't really know what you're doing and so on. I think in that situation, Jai is really strong. But the thing that for me, the thing that frustrates me the most about Jai is the LSP, so the auto-completion engine. Jonathan Blow doesn't believe in LSP, so there is no official LSP. So there is an LSP that one of the guys in the beta team wrote. I also constantly sending PRs to fix all the stuff that I find while working with my code, but it's still not perfect. And I really like LSPs. I'm really dependent on LSP. I also heard that Rust is really robust and fast at the same time. Yeah. Yes, I think potentially you can write more performant code with Jai just because the approach that languages like Jai and Zig have to memory management. This is something you can watch Casey Muratori talking about this. So if you look for Casey Muratori talking about what they call it, what was that video, Casey Muratori? The can't remember. Casey Muratori. Could it be memory management? Or Z? Yeah, this one. Go watch this video. Yeah, go watch this video. I'm gonna put the link. Definitely, if you are into programming, I also put it on YouTube. There you go. Maybe I understand why the question. I'm streaming both on Twitch and YouTube, so sometimes I'm replying to chat messages from Twitch, and you guys on YouTube don't see it. And same thing for the Twitch guys. Sometimes I reply to you guys on YouTube, and you don't see it. So this video explains really well the different approach in memory management between something like Rust and something like Jai. So, in something like Rust, memory is basically managed at a very micro level. So you have a string, so that string owns the memory. And so what is happening is that, if you need a string, imagine you need a string quickly. So you're drawing your screen, right? So you're putting a string on the screen, and you are creating a string. You're writing something like FPS equal the number of FPS you're doing, right? You're creating that string. So if you're doing that in Rust, every time you have a frame, you will have to create a string. So that's, you're hitting your memory allocator and say, hey, you're saying to the operating system, give me this amount of memory because I need to create this string. So you hit that, and then when the function exits and you're done with that string, then memory gets deallocated, right? So you have this work to create this memory from the operating system and then deallocate the memory. And in Rust, this happens with every single thing, like Rust, C++, all these systems that rely on this thing called RAII, right? So the concept is that the memory is handled by scope. So if something goes out of scope, the destructor is called and it can delete the memory under that. The concept of something like Jai is that instead of thinking like that, you think in terms of how long an object lives for. So you will have like a bunch of memory, for example, for stuff that only live for one frame. And what is happening is that you create the memory when the program starts, right? And it's big memory. So you ask the operating system one time, give me this big bunch of memory that I'm going to use for stuff that get used in one frame. And what is happening is that to create that string, you just put it in that bunch of memory that you have. And at the end of the frame, you don't send it back to the operating system. You just reset your allocator to start from the beginning again. And you overwrite everything because you know that that's stuff that only lives for a frame. So it's not stuff that you're going to need the frame after. So, and you have something that for things that live for a frame, you have something that for things that live for the entire duration of the program. So you can imagine all your stuff, that live for the entire duration of the program. You can have like an allocator with some memory with the stuff that you need every time you change a level, things like that, right? So what is happening is that languages like Jai and Zig that use this approach to memory management can be much faster. They can, at the moment, memory allocation and the allocation is one of the places where performance are lost, right? So languages like Jai and Zig, just by programming this way, they can get better performance than C++ and Rust just because of this reason. You can do something similar in Rust. Like, for example, in hydrofoil generation, at a certain point, I did do that thing that I told you about the strings. You can actually use something in Rust called bump allo, which is like bump allocator. So every time you create a string that you just have to send to the UI for one frame, you use that allocator and then you reset it. It's not the thing that is going to make a huge difference in performance. But if your entire system is built that way, it could be potentially faster. So if you had the time to deal with engine stuff, you would stick to Jai. Probably, but I also have a feeling that I will get frustrated because of the LSP. I don't know. In C++, I tend to set buffer if I need one permanently and keep overwriting with the beginning address. Yes, similar approach. But as soon, for example, you start to use things like the standard library. So the standard vectors and the standard string, it becomes a little bit cumbersome in C++ to use your own allocator. It's like, it's possible, but it's not really nice. And C++ is already not nice by default. So trying to use it that way makes it even worse. So you have, if you want to do it, you really have to go and write your own dynamic array and vectors and strings and so on. It's not nice. Memory alignment. Is that really important for single-threaded code, or becomes important in multi-threaded code when you align by the cache side? I don't know. I don't tend to go that low level, so I'm not the right guy to answer that question about alignment. C++ needs a reset. I totally agree. Well, I don't know. I in my opinion, I'm not a compiler developer and so on, but and I saw discussions in the committee about doing this. But for me, the thing is that at the beginning of a file in C++, you should have something like epoch, right? 2026, right? So you're basically saying, okay, this guy is using C++ 2026, right? And you do it by file. I'm not a compiler developer, and I understand that you will have to have different version of the compilers. I totally understand. So as usual, things look very easy when you don't have to do them. The moment you have to actually make things happen, they're much more complex. But I totally agree. It needs a reset. At the moment, it's ridiculous. And also this obsession that they have to implement everything as a library functionality, it's ridiculous. Like, for example, go check what they did with the stud variant, right? So stud variant in C++ is the example of how terrible, how clueless people are, right? The concept of variant and matching over a variant should be something that you have in a language. If you want it, you have to change language to have it. You cannot implement it as template magic. It's just stupid. No, something called like this. Something called like this, stud variant. It's something that you use to do something that is called a tag union, which is a fantastic way to organize your code. You know, Rust is super, you know, as one of the best implementation of this concept. F# also has it. It comes from functional programming. And it's a fantastic way to organize your code, and it works really well for things everywhere in your code, you know, other engine or gameplay. And but to work well, it really needs support from the language, right? It needs to be, the language needs to be able to do something. I saw that the new C# does something cool, something close enough to that. Where was it? This one. So this seems very similar to the way Rust does it. In this case, I think C# is not, it can do it, but it doesn't have the concept of real tagged union. But, you know, if you can look at enum in Rust to try to understand what I'm talking about. That's why a lot of people just stick with C and avoid C++ completely. Yeah, I agree. Obviously, there are things that you want from C++, right? You really don't want to have, you know, you really need a vector, right? And do you think it was the right decision for able to switch from the Unreal Engine to own proprietary engine? I heard they had to use a lot of workaround, as a Unreal Engine was really flexible for games where you try to simulate real life physics. No, this got nothing to do with physics. Absolutely nothing to do with physics. The thing that we didn't like about Unreal were compile times were really, really slow. Loading times were really, really slow. But, you know, we also made a couple of mistakes. Like, for example, we had like two Visual Studio solutions. So one solution included the physics that we brought from AC1 and the artificial intelligence code. I think it was also living in that solution. And that solution will create a static library. And then we had another solution that was on a real project that will link that static library. So for people like myself working on the physics and on the AI, it was an absolute nightmare, because I had to have like two Visual Studio. And because this static library was changing, at the time, hot reloading in a real engine didn't really work well. So it was not really an option. So I had to, every single time, it's like close the editor, and then, you know, go in the physics part, compile that, then switch to the other solution, compile that, start it. The editor will come up and it's like slow. And then you press play on the editor and it's slow. And it's funny because then when you play the game on Steam and you press the button to start race, you know, to go from the UI to the race, the loading times are absolutely super fast. They are insanely fast. So they're incredibly fast when the thing is built, you know, to release. But when you're in development, it's like you press on that thing to start playing and you go make a coffee. So that was one of the things that made really annoying to work with a real engine. So it had nothing to do really with the physics, because the physics, we didn't use a real engine for the physics. We were using the same stuff in AC1. So we were basically using a real engine only for the graphical part, right? Not for the physics. We were running the Unreal Engine physics. We used it for things on the game side. So things like, for example, Am I in an area where there should be reverb, like when you pass under a bridge? Like should we have reverb in the audio? Those kind of stuff. We use the Unreal Engine physics engine to do that kind of check, but all the physics stuff was our own code, so we didn't really care. And the other thing, obviously, we really miss the image in Unreal is not really clear. I remember the first time that I was driving and I was like, okay, my eyes are going bad, right? I'm wearing glasses. If you watch my streams from a couple of years ago, you see that I could work without glasses. Now I really can't anymore. But anyway, at the time when I was driving with Competizione, and I was asking Simone, hey, but did we make the things before the corner that tell you like 300, 200, 100? Like, I don't know what they call. Did you make those things smaller than AC1? Because I cannot read them, right? And it's very obvious, right? You try to play AC1 and you can read the bloody 300, 200, 100, right? And you run Competizione, it's really difficult to read. And the reason is that because Unreal is just messy and blurry by default, it's just the way they go through. There is this kid, a YouTube channel called Threat Interactive, and it just destroys Unreal. He's got all this series of videos that show like all the problems that Unreal has. And Unreal has this rendering. It's very noisy by default, right? And then they have to go over it with a pass that is kind of smoothing and blurring everything out, and that also kills the crispness and all the details in that kind of stuff. So at the time when we were discussing about the next game, that was just before I left, and those were the things that we were saying, next game we shouldn't use Unreal. Like, I think those are the main reasons, right? Yeah, no real anti-aliasing, so you're relying on temporal to do the anti-aliasing, so these small problems. I was playing Oblivion Remastered on PS5. When my character running through the world, the grass matches, yeah. What's surprising, the AC Rally, which is also based on Unreal, is quite decent. I think, well, first of all, I think Unreal 5, I did some work for 6 months for a French company, and we work on Unreal. And Unreal 5, there are things that are much better. For sure, hot reloading works really well. It's usable. It's definitely usable. So all the frustration for the compile times are not a thing anymore, because you don't have to close the editor. Because hot reload works, so at least you don't have that time to close the editor. But they don't fix. Say the temporal is still a big problem. Yeah. Yeah, and multi-sample anti-aliasing is very, very hard to beat. Right? It's really hard to beat. You do a game where you have MSAA, and you can do an additional pass of FXAA on top of it as a post-processing, and you're gonna be golden. Or SMAA. You're gonna be in a very good state. And I think that's pretty much what they're doing right now with Evo. I think is MSAA plus something else on top. I think there is a temporal, but it's an option that you probably shouldn't use. How hard it is to train new hires on proprietary engine instead of Unreal? I think if you know C++, it's not a huge difference. It's not a huge difference. And if you are an engine programmer, you want to work on your own engine and not on Unreal. If you are a gameplay programmer, it's not really that different. You just have to learn how to interact with the system. So at the end, it's C++. So I wouldn't say it's a huge. It's not like Rust, right? If you that's one of the biggest problems if you want to have a game company in Rust is hiring is going to become really big problem, because whoever you hire is gonna take, if they don't know Rust, it's gonna take 4 months before they can start to commit something that actually has some value. I will definitely write a new proprietary engine in Rust rather than in C++. Me too. I wouldn't touch C++. I just refuse. I don't like it. This experience going back to work on Evo in the last in those 6 months that I spent there, having to interact with C++ is like, after so many years of Rust and Jai, it just feels wrong. Obviously, if you want to write an engine, the nice thing about C++ is that every SDK is C++. So, you don't have to go through the pain of figuring out a binding to whatever language you use. It's all there. You want to use Jolt for the physics, is there, is C++. It's all, so that obviously there you have a big advantage. If you write in the Rust but still think it's C++, that will probably cause a lot of pain. Yeah, that's something that you have to avoid straight away. Like, for example, I think I did it in this one. I said, now I'm in C# and I'm doing things like in a C# way. Let me see, where, I have the match, the tennis match has an array of players, and the player has a reference to the match that it belongs to, right? This is the typical thing that in Rust is like, forget it, it's not going to happen. Right? If you want to do this kind of things in Rust, it's going to be pain all over the day. And in fact, when I did it, I felt dirty. But at the end of the day, it's just a very simple choice. Because the way to avoid this, instead of having a member, you have to pass it in every function. Yeah, you can, but that a lot of people will tell you that you will need an RC cell. Honestly, I did an entire game without cells, right? So it just needs a little bit of thinking, right? It's totally doable. It's a little bit more verbose because you end up with a lot of functions that have a lot of parameters, right? Because you need to pass in all the stuff that a function needs. And the cell has the annoying attribute that it can fail at runtime, right? So every time you use a cell, you are accepting the idea that the program could crash at runtime, because basically the same rules that the borrow checker is putting on you at compile time, the cell will put it on your runtime, so you could crash at runtime. So, yeah, pointer spaghetti. That it's true. It's absolutely. I think in a language like C#, where you have a garbage collector, is not really a big deal. I was out this morning. I was thinking about this. I was like, should I do it? Should I do this? I'm not convinced that I should do it yet. I told you the alternative is not that bad, right? You know, the alternative is that you have match here, right? That's it. You solve. Problem solved, right? A little bit more verbose, definitely more clear. But C# doesn't have the problem, so why going through this? Almost all GC language encourage to write and design this way, yeah. Where basically, you see what I mean? It's like it makes it really easy to go up, like, you know. So potentially, you know, because in games it's very typical that, you know, you are somewhere down and you need some information that lives somewhere else. So you want to be able to kind of go up and then go down, you know, and find what you need. Rust makes this really, really difficult to do. Impossible, I would say. Right? So you really need to think a lot how you do things. In Rust, you do a lot of things where, you know, the typical problem where you're updating your character, you shoot, and you decide that you're hitting another character and you want to kill the other character. You know, this is the typical thing that Rust will not allow you to do. Right? So usually the way you do it in Rust, one way to do it is that your update will return a series of events, right? So if you want to kill a player, if you want to kill an enemy, you basically return an event that says, by the way, kill entity number 1, 2, 3, right? And after you're done with all the updates, you go through the event and it's like, okay, so this guy's dead, and so on. A little know nothing about Rust. This already sounds weird to me. Yeah, if you that's really the only suggestion that I would say. Like, if you decide to, I think everybody, if you're serious about programming, you should learn Rust, because it will teach you a lot of very good stuff. But you need to go in with, you know, prepared to learn new things, right? It's not a language where you can go and redo the things the way you do it in another way. Am I done with Rust? I don't know. Like, you know, this week I'm having a lot of doubts. You know, I was having a lot of doubts finishing, you know, continuing the game in Jai. So I started to think, oh, maybe I should switch back to Rust. Just because the tooling in Rust is absolutely fantastic. When I say tooling, I mean, you know, the LSP, so all the stuff that I have in Visual Studio Code that help me to navigate the code, complete the code. That stuff in Rust is absolutely fantastic. It's really great, and I really like. It really forces you to really organize your code. Like, it really forces you. But at the end of the project, like I was saying at the beginning, it really pays. But then, you know, so I was really doubting my decision to go with Jai. But then now, you know, I'm in a completely even more extreme position where I really don't want to write the rendering stuff that I need. So that's why I'm considering very strongly Godot, because it just removes like 50% of work or even more, right? And it's like, all right, okay, all the engine stuff is taken, you know, all the things that I will have to code, like, you know, eventually we want this character to move, we want this hair to move, right? As the character is moving, we want the hair to move, the skirt to move. These are all things that they should be already in in Godot. It's just a matter of learning how to use it, right? Instead of going and coding it myself, I prefer to concentrate on the game. No, I think my wife went for. I told my wife, let's have the shading in Godot is not as good as mine. I told her let's have an anime girl with horns, but I think she went more for the K-pop Demon Hunter. I don't know if you guys saw on Netflix. So she went more for that style. So I think we need a little bit of work. So the we was here. Was that Rafael Manager? No, it was no. Steve from YouTube is asking if Hydrofall Generation was made in Unigine. I went through a very similar phase in Unigine at a certain point. I think after 6 months of development, so I started in Rust. After 6 months, I was like, oh man, this is really hard. And I started to do some experiment with Unigine, exactly like I'm doing right now with Godot. Very similar situation. So after 6 months, I switched basically to Godot and I rewrote the entire thing in C++. But then I hit a wall with Unigine because I couldn't get the water to sync in multi-thread, and I absolutely needed that for multiplayer. And it was just impossible. I got in touch with the developers. They are super nice guys, the developers of Unigine. But I couldn't get it to work. And there is something very interesting. There is something very interesting that happens when you use an engine. One thing that is nice about the engine is that, in something like Godot, I can go here and start to play with, all the rendering stuff. So I can turn on and off things like, ambient occlusion and the tone mapping and the global illumination and blah, blah, blah. And this allows me to understand what I need, right? So what happened to me when I was working with Unigine was like, okay, so now that I worked with Unigine for another 6 months, I understand what I need to make the game look good. So I was like, okay, I really need the reflections over the water. I really need the PBR system material and so on. So it kind of, okay, this is what I need to do. Right? So it cleared my mind of what I needed to code in my own engine. So when I went back to Rust, for me, it was like, okay, this can, unless I'm able to do the code to do the reflection of the boat on the water, I cannot do it with Rust. So I went back to Rust, and basically, to answer your question, Unigine was just a small window between the two Rust implementation. So the game is in Rust. I also want to try Godot, but with game engines, I'm kind of afraid when I put my own code and how long it will take to learn. Yeah. The thing is that I always enjoy trying things. So, I always try stuff in Unity. So I'm familiar with Unity, with C#. So for me, Godot is like almost zero time to learn. It's really simple. It's really I know that there are things from the performance point of view, especially when it comes to physics, that are not great. The way you interact with the engine is from a performance point of view. All these things, a lot of stuff is based on dictionaries, on strings, is not ideal from a performance point of view. It's very convenient, but it's not ideal. But it's nice that you have the option to go to C++, right? You can go C++ either through an extension or through the main source code and if you want to add your super high performance stuff, you can. Right? So if you start to do something and then you hit a wall and you go like, oh shit, this thing is really slow, you still have the option to do something else. I love the fact that there is no installer. You just download a zip file and you launch it, and that's it. I love the fact that it comes up. So I started, boom, and I'm in, right? It's not Unity, it's not Unreal that it's like, it's not like 3 million gigabytes of download every time there is a new version. I like the fact that from Visual Studio Code, I can just start the game. So this feels very similar, and now it doesn't start because I'm talking so much that I'm not writing the code. But I can basically start from Visual Studio Code, and it just starts the game almost as I'm writing my own engine. So it feels nice. It feels nice. How do I do that? You create a launch file. So you create this thing where you basically say, I want to start wherever you have your Godot, the scene that you want to start, right? And this is basically the configuration for your debugger. So you choose which one you want to have. So in this case, press F5 and it starts. So it's really convenient, and so you don't even have to open the editor, right? You can work, from the code. Think about Unity, right? Unity, you're writing the code, then I save, right? I save here, then I go back to Unity, and Unity goes like recompiling domain, blah blah blah, and you have to wait, and then you have to play in Unity, and it goes like, oh, reloading domain, and it takes ages to start playing. Right? So it's not. I'm really big in having a workflow that is not frustrating, right? And I find that potentially, obviously, the problem with when you use this kind of stuff is that it's easy to be fast when you have nothing. Right? When you have a very simple scene and, very few code, it's easy for things to feel snappy. And the reality is that until you have the more the project will get bigger, the more these things will become slower. And you will never know until you're there. And by the time you're there, it's too late to change back. The thing is that you build the code to check it, yes, and then but then all you have to do is launch Godot and pass as a parameter the scene that you want to launch, and it will execute. So you can also do it, by terminal, right? So if I do this. So if I go in my, and I go do this, and then I do scenes, what is it, game scene, TSCN, right? It starts the game, right? So it's not starting the editor, it's starting this scene. It's very convenient. Yeah, it's super fast. It's really cool. Yeah, because you build the DLL, but then the scene file has all the references, so it loads what it needs to load. Right, I'm converting people to Godot. It works really well. So the first impression is good. I have to say, it's good. It's going to be a much more convenient way to debug instead of having to grab the PD of the process. Yes. Yeah. That if you really have to do that, then you're going to find a much better quality of life. It's amazing. I was searching it 2 days ago, watching videos. Well, I think it got a really big push from Unity. When was it? 6 months ago that they did all the noise for that problem. The change of licenses or whatever. All right. Do we have does C# have local functions? Does it? It looks like it does. So let's implement this apply friction. Very simple function. So if math f abs is less than friction, return 0. Otherwise we return so cool that it's got local functions. Okay, so oops, the math f, oops, math f abs cool. Yeah, I just went for it because my Jai version had it as a local function. So I was very dubious. So bounce, well, course data bounce, position y, the radius. Okay, so here we need public bool did bounce. Did bounce. Okay, and then var spin component is spin. Am I passing the spin? Yes. Per spin factor. Where is the spin factor coming from? The spin factor. Is it a local constant? Spin factor. Yeah. const float spin factor. One thing that is not working super well is this. The error lens sometimes get confused. So that's not great. Gravity. Where are we going to put gravity? Because in one thing that I cannot do is this, right? Const float gravity. Can I? I don't think so. By the way, it's a server. I can have a global like that? Ah, okay, because this goes in the top statement. Okay, so we need to put this somewhere. Let's put it in math for now. So GV math gravity. Okay, what is your problem? Invalid expression? What? Okay, so this is building. See, this one didn't clean, so it's it builds correctly, but this doesn't go away. Whatever. All right, so what we have now, we do a step once, but we're still not done, because then we have to put it in the result. So the result will have public vector3 pos, public vector3 val. So at the end, our result is gonna be res pos equal pos, res val equal val. Should work, right? So our step here now is var equal step once, and we pass in pos val 0 spin, and we need the court data. So here we can do the same thing that we said we don't want to do, but match, right? And match is going to have match court data, right? So in match, we're going to have a court, right? And this is going to be this. Should all be good. What else? DT. Okay. And then we do pos is res pos, val is res val. Very simple. In theory, the ball should bounce. Let's see. I think you're missing a namespace, so the compiler assumed the default is why it worked. You mean the local variable? Oh shit, I missed the bounce. Did it bounce? The ball? Yeah, it's bouncing. It's very difficult to see. Is there a way to start it in full screen? Godot parameters. Command line parameters. Is there a way to start it full screen? Separates engine, argument, project manager, editor, path, scene, full screen, maximized. Oh. Do I want to do it though? Let's do it just to try 1 second. We want to see the ball bouncing. So arguments, maximized, like that. Maximized. All right, does it work? Yes, it works. Okay, we can see the ball bouncing. You know what? Instead of doing it here in the debug, you know what I can do? I can do it. I have a task that is actually starting the thing without the debugger. And we can make it here start maximize. So basically, if I want to just play, maximize. Or I can even try full screen. Let's try. Run. Boom, full screen. That's so cool. The problem is that now I don't know how to exit. Alt F4. So you were saying about, you think you meant the gravity thing. So you reckon that I can do a namespace. So I can do a namespace physics and put a constant in it. Like that? No. A namespace cannot directly contain members. Nope. Doesn't work. All right, so the ball is bouncing. So what are we going to do now? Then what can a namespace contain? Classes. So this is like Java. C# is like Java, right? Everything has to be inside the class. And then you have the new C# stuff, which is the top level statement, whatever it is, but that's just executing code. So it's like a main function. So something they did in there, but everything has to be inside the class. So for example, so this constant, I had to put it inside this class. But it's good enough. I think it's good enough. So what we want to do, are we already counting the bounces? No. All right, so what's going on here? So did bounce true. So what we have to do here is that if result did bounce, then bounce count plus, does it work? The C# has plus plus. Oh, cool, plus plus. All right, okay. Okay, so here what we want to do basically is that if bounce count, let's say that if we bounce more than 5 times, it's very nice, more than 4 times, okay, what we're going to do is we're going to have a new function which is called public void hit, right? And this is going to be a vector3 new velocity and spin, load spin, that we're not using right now, right? We don't have the spin, it's fine. So vel is new vel, okay? So its bounce is more than this, and when we hit, then bounce count becomes 0. We're gonna do hit, and we're gonna do new 0, 5, and 15. So the only question is if we got our signs right, or signs correct. So either the ball is gonna go there, or it's gonna go opposite. So let's run it. Bytekeeper, how you doing? Okay. 4 bounce, boom. I didn't see the ball is so small. That's so okay. This is something that what's going on? What's going on? So we threw the ball the first time. Ah, okay. Let me put the position. Right, okay. So we put the position. The position, we're going to put it at 0, 1.5 minus court half length by 1.3. Okay. All right. Okay. So the ball is coming from behind me. I don't know if you can see it. It's not that easy to see. There's one thing that we absolutely need is the motion blur on the ball. Let's get the ball to go a little bit faster. All right. Okay. And let's invert everything. So we're going to go from the top. So we want the ball to come to us. So the ball comes and let me enable the gamepad 1 second to show what we want to do. Player step player player input get gamepad state. Plain low poly, anche io al momento mi sto dedicando a Godot. Un abbraccio Davide, grande. Right, so the ball is coming to us. So what you want to do is prepare, boom, hit it, right? So boom, right? At the moment we don't have the code, so it's like visual thinking. I think while we're waiting for the motion blur, let's make the ball bigger so we can see it, because I really cannot see it. So so the question is, if I change the scale of the ball, is the position going to be influenced by that? I don't know how Godot works. So where are we? It was in match avatar, isn't it? That we create the ball. So here we create a ball node. So what happens if I do ball node? Just make 5 balls. Yeah, eventually that's how I did the motion blur. I'm going to show you in 1 second the difference. Like in the Jai version that I have, look what a difference the motion blur does. So there are 2 things. The ball is really bright, and look the difference the motion blur does. Like you can really see the ball very clearly, right? And before I had the motion blur, I had to do this that I'm doing right now. I had to make the ball bigger before I see it. So ball node scale What I don't know is if the, let's see, if the thing is influenced, the ball should start higher. Looks good to me. Yeah, and now we can see the ball, right? Also, the thing, I have it on the wrong key. Let's make a Mario Tennis. Let's go, Mario. What I heard about Godot, collision were automatically calculated. Yeah, I'm writing all the physics by hand, so I'm not really going through the Godot physics engine. Like a watermelon. Yeah, exactly. Right. What are we doing? I thought about something and I forgot. Yes, I want to change 1 second that the gamepad, get gamepad state. Inputs. Right, we want X for the shot. Right. So yeah, so what we want to do, we want to be able to get in position and hit the ball. Right? When I get here, yeah, and boom. All right, let's do that. And then I think it's time for me to get some rest. All right, how are we going to do this? So in the player step, when we are swinging, so when we're swinging, new shot time is going to be shot time I think it's like this. And the idea is that if new shot time is more than swing time, if shot time is less than swing time, and the new one is more, okay, we have to check if we hit the ball. Right, so I can either write a function ball, for now ball, check ball hit, right? Easy. And we do if, let's do super simple, if mat f abs between pos z minus match ball pos z is less than 1.5, right? And also laterally, we are within 1.5. That's it. That's it. This is gonna get way more complicated, this function. By comparison, the same function in Jai looks like check ball hit. Yeah, that's the one in Jai. It's not huge. For now, I don't want to copy it. I just want to see that ball going on the other side because I'm really tired. You know, it's 7 o'clock Saturday here in Australia. And I've been at this since 6 o'clock this morning. So I think it's time for a break. So check ball hit. So the idea here is that if this and let's do it like this. If check ball hits right, we do match ball hit with a new speed of 0, 5, and what was it? 21 multiplied by minus sign of my z-boss and spin 0. No, that's it. Should work. It should work. Let's see. Let's see. Boink. And boom. Okay. It did work. Boom. It looks like it's bouncing. What's going on here? Okay. Looks like it's working. All right. So far, so good. And I think we can be happy for the day. So this is what we have, and this is what we want to have, right? So this is what we have to port, basically. So tons of stuff missing. Artificial intelligence, proper thing, camera movement. See, the camera is rotating here. Motion blur for the ball. But yeah, we're gonna make it. We are going to make it. Moon bowling. Look at these pushers. Alright guys. Ciao Stefano, grazie per questa live. Ho appena scoperto, ma per realizzare un gioco del genere usi dei design pattern. SSS is asking about if I'm using design patterns. I answer quick in Italian and then I translate to English. Onestamente no, cioè no, nel senso che non ho mai studiato pattern specifici. Ogni volta che li ho guardati ovviamente sono cose che uso, ma che ho scoperto. Devi pensare che, cioè, che faccio sta roba da quando avevo 10 anni, quindi adesso ne ho 53, quindi ho 43 anni sulle spalle di questa roba, quindi non penso neanche a quella parola. So the answer in Italian was about design patterns is that I don't really think that way. For sure I have patterns in my head that I tend to use, but they don't come from studying, you know, the famous book. There is a famous book called Design Pattern for Games or something like that, which is an interesting book. I think what is called Design Pattern for Games, something like that. Design Pattern for Games. Was it this one? There is also a book. Yeah, I mean, my answer is that obviously, yes, I use, you know, pattern, but I didn't learn them as patterns. I just learn them by doing it. Right. Walking forward and backward. Yeah, we don't have the animations for the. We don't have the animation for the run, so it's basically just it's just running the idle animation. So this is like an idle animation. So we don't have the animation yet. This book, Game Programming Patterns. There you go. Let me put it on YouTube because the Game Programming Pattern. Copy current address. All right. SSS, ti metto questo link, se ce la faccio, ce la posso fare. Sono pattern specifici per i videogame. Ti ripeto, io anche se uso qualche cosa non la uso conoscendo il nome. All right, guys, have a fantastic Saturday, and I will see you next time. Ciao, 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 ciao.